Okay, sorry about the rough ending on that last one, but I realized that these next two are a little bit different than a standard molarity problem. Oh, sorry, next three. My bad. Next three problems are a little bit different than a standard molarity problem. I consider them to be something along the lines of solution stoichiometry more than anything else. And remember that stoichiometry is whenever we're going through and using coefficients to balance things out. But I think you'll see on this one, we can do our equations and balance them out a little bit different than the way that we've done it in the past, but a very, very easy application. So this problem right here says, given a 0.50 molar solution of cobalt 2 nitrate, calculate the concentrations of all of the ions in the solution. So it says right here that I have 0.50 moles of cobalt nitrate per every liter of solution. That's what 0.50 molar means. But what you've got to think about is how cobalt 2 nitrate translates into its ions. So think all the way back to Unit 4 when we were talking about net ionic equations and all of that good stuff. We went through and we could split compounds up into their ions, okay? So I know that for every cobalt 2 nitrate that I have, it's going to split up into two different sets of ions. It'll split into a cobalt ion, and you've got to think to yourself, what's the charge on that cobalt ion going to be? Well, nitrates each have a -1 charge, and there are two of them, so this must be cobalt plus 2. And then I'm going to have two nitrate ions, NO3 minuses. Okay, so let's just assume, hypothetically, that I have 1 liter of solution, right? That means that I have 0.50 moles of cobalt nitrate. If I have 0.50 moles of cobalt nitrate, how many moles of cobalt ions do I have then? You're going to have 0.50, because every single one of these is going to produce one of these from my balanced equation. Okay, so because this was 0.50 molar, this will be 0.50 molar. And what gets a little bit trickier though is that there are two of these. So for every one of these, I'll have two of these. So my concentration is going to be double. It's going to be 2 times 0.50 molar. So my final concentrations will be 0.50 molar cobalt ions and 1.0 molar nitrate ions. Now this concept right here is a little bit hard for some people to wrap their heads around, but just think about it. It's like going back to making cheeseburgers, okay? We love to talk about cheeseburgers in here. Think of this right here. My nitrates are my bread. My cobalt is my burger. This is my cheeseburger, and I have 0.50 moles of them for every 1 liter. That's a lot, right? And if I split them up into my ions, I will always have the same number of burgers as I did my cheeseburgers, and I will always have 2 times as many pieces of bread as I do my cheeseburgers. So because of my subscripts now in the compound, it changes the coefficients that you have in your equation. All right, so let's do another one just to practice. So this one says, how many moles of silver ions are present in 25 milliliters of a 0.75 molar silver nitrate solution? So I'm going to start out with